Every time your AI agent makes an API call, you are paying for the entire conversation history again. Every tool call. Every result. Every system prompt token. From scratch. A single Claude session with a 50,000 token context costs 67 cents per run. But here's the thing, major providers have offered prompt caching for over a year. And properly configured, it drops that cost to 8 cents. An 88% savings. But, and this is the part nobody tells you, caching everything? That can actually make your agent slower. Let's understand why agentic workloads are uniquely expensive. A standard chat session has a short context, ask a question, get an answer, done. But an agent session is different. Every turn, the agent calls a tool. That tool call and its result get appended to the context. Next turn, same thing. After 30 turns, you're sitting on 50,000 tokens or more. And here's the killer, every single turn charges you for all of those tokens, including the ones you already paid for in previous turns. That's the fundamental inefficiency that prompt caching is designed to fix. But before this paper, nobody had actually measured how much it saved. Behind the scenes, every LLM call computes something called KV tensors, the key-value representations from the attention layers that capture what the prompt means. These tensors are expensive to compute. Prompt caching simply stores them. On the next call, if the prompt starts with the same prefix, the provider skips recomputing the cached part and only processes what's new. The trick is that providers set minimum thresholds. OpenAI and Anthropic need at least 1024 tokens before caching kicks in, Google needs 4096. And the cached data has a time to live, anywhere from 5 minutes to 24 hours, depending on the provider. Miss the window, and you pay full price again. The paper tested 3 caching strategies across 4 models, GPT 5.2, GPT 4o, Claude Sonnet 4.5, and Gemini 2.5 Pro. Strategy 1, Full Context Caching. Cache everything, system prompt, conversation history, tool calls, tool results. Strategy 2, System prompt only. Cache just the stable instructions, everything else fresh each time. Strategy 3, Exclude tool results. Cache the system prompt and conversation, but skip the dynamic tool outputs. 500 agent sessions on Deep Research Bench. And the results were surprisingly clear. GPT 5.2 with the exclude tool result strategy, 79.6% cost reduction, 13% faster time to first token. Claude Sonnet 4.5 with system prompt only, 78.5% off your bill, and almost 23% faster responses. GPT 4o, 46% cheaper and a staggering 31% faster, if you use the right strategy. Gemini 2.5 Pro, 41% cheaper, but only 6% faster on latency. Across all models and strategies, the range was 41 to 80% cost reduction. Time to first token improved by 6 to 31%. Those are not marginal gains. Those are production-changing numbers. But here's the paradox. GPT 4o with full context caching, caching everything, including tool calls and results, showed an 8.8% regression in time to first token. It got slower. Gemini with exclude tool results also regressed. Why? Because caching dynamic content triggers a cache write on every request. You're spending time writing to cache that never gets reused, the tool results change every time. The overhead of writing to cache exceeds the benefit of reading from it. The lesson is clear, the system prompt is the stable, reusable part. Tool calls and results are ephemeral. Cache the workbench, not the sawdust. The paper also ran ablation studies to understand what drives caching benefits. 2 dimensions, prompt size and tool call count. 6 prompt sizes from 500 to 50,000 tokens. 5 tool counts from 3 to 50 calls. The results were unambiguous. Cost savings scale linearly with prompt size. At 50,000 tokens, GPT 5.2 hits 89% savings, dropping from 25 cents to under 3 cents. Claude hits 88%. Tool call count. Almost irrelevant. Whether your agent makes 3 calls or 50, the savings stay within 10 percentage points. The system prompt length is the dominant factor. Period. So what do you actually do? 1. Use system prompt only or exclude tool results caching. Never full context, it can backfire. 2. If you have dynamic content like timestamps or session IDs, put them at the very end of the system prompt so the cacheable prefix is maximized. 3. Avoid dynamic function calling. If your tool set changes between requests through something like MCP, every change invalidates the cached prefix. Use code generation for dynamic capabilities instead. 4. Make sure your prompt exceeds 1024 tokens, below that, caching flat out doesn't activate. Follow these rules, and you'll cut your agent API bill by up to 80%. And your agents will actually respond faster. Check your agent system prompt right now. Is there a timestamp, a session ID, or a dynamically changing tool definition in there? If so, you're breaking the cache on every single call. Drop your setup in the comments. I want to hear what caching strategy you're running in production.